Hello and welcome. Let's talk about type projections, which is related to type variance. When using type parameters, generics, there is a distinction between use site and declaration site variance. Use site variance is the term used when the variance of type parameters is set by the variable itself. This is how it's done in Java. The variables will set the variance. Declaration site variance is the term used when the type or the function determines the variance, as in Kotlin. This is when you specify out and in. You're specifically saying this is the variance. It's either covariant, contravariant, or if you don't specify anything, it has default invariant. Okay, so declaration site variance is what Kotlin uses. Use site variance is what Java uses, even though everything in Java is invariant. It's very convenient to declare a type parameter t as out and avoid trouble with subtyping on the use site. However, some classes can't be restricted to only return t's. You don't want to do this. This makes it inflexible. So you don't want to declare everything as covariant with the out keyword. So here's an example where we have an array class of t and it has a size as a name parameter of type int. And we can say get on those parameters and we return those t's. This class cannot be either co or contravariant in t because it imposes certain flexibility. So you wouldn't want to specify out or in with this example. Another example here is you have a copy function and we have two named parameters from and to that take an array of any types. First thing we're going to do is we're going to assert that the sizes are the same because you can't copy if the sizes are different. We're then going to start iterating through the indices in the from, and we're going to assign them to the to. This function is supposed to copy items from one array to the another. All right, so we could use it like this. We could say array of 1, 2, 3, array of ints. We could create an array of any objects of 3 that are empty quotes. If we try to copy the ints to the any, we get an error. It expects array of any types for both. Okay, so we run into the same familiar problem. Array t is invariant in t, thus neither of array int or array any is a subtype of the other, so you can't use it. We would have a class cast exception that would occur in this case, because by default in Kotlin, remember, it would be invariant because we didn't provide out or in. And so if we tried to copy ints to any, it wouldn't work because it expects any types. And this is a familiar problem. So if we want to ensure that copy does not write to the from, we can do something like this. We can use a type projection. We can say from array out any to array any. And so we said the from is not simply an array, but a restricted, a projected one. This is what we're doing right here. We're putting the out as part of the generic type in the parameter. We can only call those methods that return the type parameter t. So this corresponds to the Java's array where it has a question mark. Remember we talked about the question mark and how this is, you don't know what it's going to return, so you say you're not sure, so use the question mark, extends object. But we do this in a slightly simpler way. We do this type projection with our out keyword as our type, and we're saying from can be covariant, but the to has to be any. We can also do the type projection within. You can project the type within as well. Here you would do something like in string for our array. And what this is saying is it corresponds to Java's array question mark superstring. You can pass an array of char sequence or an array of object to the fill function. You can also, there's a concept called star projections. This is when you want to say that you know nothing about the type argument, but you still want to use it in a safe way. So the safe way here is to define such a projection of the generic type that every concrete instantiation of that generic type would be a subtype of that projection. So you'll use this with the nothing type. The nothing type we've talked about how we can use the nothing type to say that we're not returning anything from a function. We use this often when we have like an infinite loop. It's not returning anything. You can also use the nothing type, which is a subtype of all other types. It's the opposite of the any, and it's often used with the star projection. So with the star projection syntax, you can use it to indicate that you have no information about a generic argument. So if you have foo and you say out t, where t is a covariant type parameter with the upper bound t upper, foo star is equivalent to foo out t upper. So this means that when t is unknown, you can safely read values of t upper from foo. You have that safe typing and you're still using a constraint. If you say foo for foo in t, where t is a contravariant type parameter, foo star is equivalent to foo in nothing. This means there is nothing you can write to foo in a safe way when t is unknown. Nothing is the opposite of any. So for foo t, where t is an invariant type parameter with the upper bound t upper, foo star is equivalent to foo out t upper for reading values and to foo in nothing for writing values. So if a generic type has several type parameters, each of them can be projected independently. If the type is declared as an interface function in t out u, you could do something like function star string. This means function in nothing string. Function in star means function in out any question mark null. Function star star means function in nothing out any. So this is where you can use these star projections. Hopefully that makes sense. It's a way to have some type safety on a parameter with automatically specifying the bounded parameters, the constraints. The star projection syntax can be used with the exact type arguments are unknown or unimportant. So you use it in that case. Let's look at some examples. So we're going to create a function called print first, and that's going to take a star projection. You see the asterisk there inside the angle brackets. That's what tells you it's a star projection. So we have print first, takes a list, and it has a star projection. And so if the list is not empty, it's going to print out the first element. And so we can call this, because we don't know what the types are going to be, we can have our main function call this with strings, and we'll see the output. So we can say print first list of Svetlana Dmitry. When we run this, it's going to print out Svetlana. So we use the star projection because we weren't sure if it was out or in, and it was inferred by the type declaration here. Another example here is if we don't use the star projection and we pass in the string. So let's define this with just types with no outs or ins and no stars. And let's call it the same way. You see there's no problem because it's doing the out automatically. It's invariant. So invariant will automatically do the out in some cases. Here's another example of a collection that takes a star projection right here. And what we're doing is we're creating a variable int list. We're casting it. We're doing a safe cast to our list int, or this is a actual cast. And we're throwing in a casting to an int, and we're using our Elvis operator to say if it is null, throw in a legal argument exception. We're going to call this by creating a list of 1, 2, 3. So now when we call that with 1, 2, 3, we're going to sum it, and we have our projection there, and it's going to be equal to 6. So another example of the star projection and how we can use it with safely with the casting and the Elvis operator. I don't use the type projections a ton, the star projection occasionally, but just try to understand what it does with the covariant and the invariant, covariant and contravariant types. Thank you.